This is the second half of the final exam part 3 review. Um, this is the back half of the page of part 1, which you probably just saw that video. So let's get started with number 3. Number 3 is different from number 2 because now I have an x on top and on bottom with our rational fraction. So when we see this, you won't be asked transformations because it's impossible to do them, but you will be asked everything else. So let's start going through that. Just like before, let's start with the asymptotes. Vertical asymptote is still, just like before, we take our denominator and we set it equal to 0. So if we did 2x minus 6 equals 0, plus 6 plus 6, 2x equals 6, divided by 6, divided by 6, x equals 3. That tells me my vertical asymptote is x equals 3. Vertical asymptote, if there's an x on the bottom, set the bottom equal to 0. That'll get you your vertical asymptote every time. That means our vertical asymptote is that piece right there. The horizontal asymptote, the rules are going to change when it's top and bottom with an x. So when that happens, we're going to take the coefficients, the numbers out in front of x, and divide them. 4 over 2 is 2. That means our horizontal asymptote is y equals 2, which is that piece right there. As we know from earlier, end behavior, when there's an x in the bottom of our function, end behavior always approaches our horizontal asymptote. So in this case, that would be 2. Then if you were to punch this in the graph in the calculator and hit Control T, you would see the points to negative 6.5. 3 would be undefined because that's where we land on the asymptote over here. And then you would get 4, 10.5. So 2, negative 6.5 is right there, meaning our graph, it's going to hug the asymptotes like that. And then we have the point 4, 10.5. It'll still hug the asymptotes just like that. Domain, just like always, we read it left to right. So as we go left and we're coming over, it's going to jump over that asymptote at positive 3. So our domain will be set notation as a squiggly line x. X is less than 3 because we jump over the 3. And that shows us this piece right here. That's the domain of that piece. Then we do U for union. Then x is greater than 3, which is the domain of this piece right here. We put union to show that they're together on one graph. Yeah. Interval notation would be negative infinity to 3, union 3 to infinity. Inequality would be the same thing as set notation without the squiggly line, so x is less than 3, union x is greater than 3. For the range, same thing, but down to up. We always read range down to up. So it starts at negative infinity, comes up. It jumps over that 2 and continues on up. So it would be y is less than 2, union y is greater than 2. Close squiggly line. Negative infinity to 2, union 2 to infinity. Please ignore that trumpet sound. That just means I got an email. Inequality would be y is less than 2, union y is greater than 2. Let me clean that up a little bit for you. So that's how you get the attributes when you have a rational function with an x on top and bottom. Jumping down to number 4, 5, and 6, these are These are a little bit different. These are not graphing. So what we're going to do for number 4, 5, and 6 is we're going to simplify these. When I ask you to add, subtract, multiply, divide, simplify rationals, rule number 1 is factor everything. Everything needs to be factored. So for simplifying, all we're going to do is factor and reduce. So for number 4, the top piece is a GCF of 6x. GCF, again, reminder means greatest common factor. We could divide both of those terms by 6x. And what that leaves us with is 2x minus 5. The bottom has a GCF of 10x squared, and that leaves us with 2x minus 5. If you need a review on factoring, I suggest going back to a final exam part 2 review video, because that entire front page is factoring. So from here, we're going to simplify it. The single numbers out front, 6 over 10 will reduce to 3 over 5. X over x squared. If I have 1x on top, 2 on the bottom, that 1 on top will cancel out one of the ones on bottom. So I'm left with just 1x on the bottom. And notice I have a 2x minus 5 on top and bottom. They're an exact match inside parentheses. If it's an exact match, they cancel each other out. So all I'm left with is 3 over 5x, and that is our final answer. Number 5, again, simplifying, so we're going to factor and reduce. Number 5, there's a GCF on top of 4, so we'll factor out the 4. And that's going to leave me with a squared minus 9. What you should notice right now is that you can factor that further. A squared minus 9, those are both perfect squares with a minus sign, therefore difference of perfect squares. We can factor the top to be 4a plus 3, a minus 3. On the bottom, there's a GCF of 8, so I get 8, a plus 3. Now the a plus 3 and the a plus 3 are exact matches, so those will reduce. 4 over 8 will reduce to 1 over 2. My final answer is a minus 3 over 2. Number 6, the top is a trinomial, so we'll add and multiply, adding to negative 13, multiplying to 40. That will be n minus 5, n minus 8. The bottom piece here, let me erase this to give more room for us. The bottom piece is a rainbow method. How do I know that? It's a trinomial with a number out front of x squared, or in this case, n squared. Remember when we do rainbow method, we take that front number, rainbow it over to the back, and multiply it. Now it's just like a regular trinomial, which will be n plus 1, n minus 15. That multiplies to 15, adds to negative 14. Then the last step with the rainbow method, take that number that you rainbowed out in front and divide. I'll start with the second one. 15 divided by 3 is 5, so I get n minus 5. This first one, the 1 does not divide by 3, so it comes up in front. I get 3n plus 1. So that ultimately we'll get n minus 5's cancel each other out. I have n minus 8 over 3n plus 1. Now some of you may be tempted to try to reduce this further and cross out the ends. That does not work. If you see terms attached to a plus or a minus sign, like that n and 8 are attached to the minus, the 3 and the 1 are attached to the plus, if it's attached to a plus or minus sign, it does not reduce unless it's an exact match, like these n minus 5s. N minus 5 and n minus 5 is an exact match. That means that is our final answer. Again, I'll erase this to give us some more room to work on these problems on the bottom here. Seven, 8, and 9 is division. We're only going to focus on division next today. We'll worry about adding and subtracting on part 4, which is coming soon. So again, rule number 1, factor everything. So number 7, this first rational here, the top piece has a GCF of 5. Therefore, we'll factor it 5y plus 1 over 2. The second guy on top has a GCF of 5 also. That'll be 5. I'll get 5y minus 4. The bottom has a GCF of 8y. I'll get 5y minus 4. Now remember, division is very similar to multiplication again, but with one extra step in the beginning. We're going to keep the first rational, so we'll keep him exactly as he is. Then we're going to change that division to multiplication. In the second one, we're going to flip it. So we get 8y, 5y minus 4 over 5y minus 4. If you remember in class, we made the joke, ketchup, mustard, fries, to help us remember what to do when there's division. We keep the first one, change division to multiplication, then flip the second one. From here, you could start reducing if you so choose. Me personally, I like to multiply and then reduce. I think it saves a step. So we'll multiply this out. On top, these solo terms out here, we'll multiply them together. 5 times 8y is 40y. The parentheses, we can just jam them together. So y plus 1 and 5y minus 4. On bottom, we have 2 and 5. That gives us 10. And 5y minus 4. Then we will reduce. The 5y minus 4's cancel. 40 over 10 reduces to 4 over 1. My final answer is going to be 4y, y plus 1. We could put over 1 if we want, but ultimately, that is our final answer. So take a second to look that over, make sure you understand it. Again, if you have any questions, feel free to come to class with those in order to help you better understand this if you need me to explain anything further. For now, I'm going to erase this problem so that number 8, so we could have more room for number 8. If you need more time to copy this down, just hit pause for a second. Number 8, again, division. So step 1 is, once again, factor everything. Number 8 on top has a GCF of 2. So I get, let's factor this in pieces because some of these have 2 steps worth of factoring. The top guy has a GCF of 2, so I pull that 2 out. I get c squared plus 2c minus 3. And then I'm left with a trinomial right here, so add and multiply. I'll get 2 c plus 3 c minus 1. That'll be the top of our first rational. Our second rational is rainbow method. I won't take the time to go over that because we just did one. However, if you need more practice on rainbow method, there's plenty of that in final exam part 2 review. Ultimately, it's going to factor to 4c minus 3 and c minus 1. The top has a GCF of 16c. And then we're left with c plus 3. The bottom is a difference of perfect squares, 2 perfect squares and a minus sign, so I get 4c plus 3 and 4c minus 3. Now again, we factored everything. We have division, so we will keep it, multiply it, and flip it. So we get 2c plus 3 c minus 1. Clean that up for you. Four c minus 3 c minus 1. Change it to multiplication, and then flip the last one. Sorry, that was 16c. Then we multiply it together. So we get, there's going to be a bit long, but again, multiplication is just jamming it together. So we get 2c plus 3, c minus 1, 4c plus 3, 4c minus 3. On the bottom, we get 16c, 4c minus 3, c minus 1, c plus 3. And now we reduce. 2 over 16 becomes 1 over 8. The c plus 3's cancel out. Sorry. The 4c minus 3's cancel out, and the c minus 1's cancel out. So our final answer will be 4c plus 3 over 8c is all I'm left with on the bottom. Again, that 4c over 8c does not reduce because the 4c on top is attached to that plus sign. So it cannot reduce. I know this one took up a bit of room, but that is the whole problem right there. Again, I'm going to erase this in order to create room for number 9. If you need to hit pause for a second in order to copy the rest of this down, feel free to do so. I'll give you a second to do that. Okay, so number 9. Again, factor everything. So the top piece is a difference of perfect squares. We get w plus 9, w minus 9. The bottom is a rainbow method. We get 4w minus 1 and w plus 7. Again, part 2 has plenty of rainbow method practice. Divided by, on top here, we'll get w minus 9, w plus 4. On the bottom, we get w plus 7 and w plus 4. Both of the top and bottom there are trinomials, so all we're doing is adding and multiplying. Then we keep multiply flip. So w plus 9, w minus 9, 4w minus 1, w plus 7 times w minus 9, w plus 4. Oh, sorry, I did not flip it. W plus 7, w plus 4, w minus 9, w plus 4. So we've factored, we've kept multiplied flip. Now we'll multiply it all together. We get and finally we'll reduce what we can. So the w minus 9's will cancel out. The w plus 7's will cancel out. The w plus 4's will cancel out. All we're left with is w plus 9 over 4w plus 1. And that's how you do division. Again, we'll hit adding and subtracting on part 4. If you need more practice with this or have any questions, please feel free to ask those in class. Like to thank my second period class for being patient while I do this. Thank you again.